solve a system of equations using elimination that's a little bit more advanced than the last one. In this one, there's no obvious way to eliminate one of the variables. Whether I add or subtract the x's, I'm not going to get 0. If I add or subtract the y's, still not going to get 0. However, if I take this top equation and I distribute a 2, in other words, multiply each part of this equation by 2, I can make this y value eliminate. Let me show you what I mean. I'm going to start by multiplying each section of this equation by 2. So what I'm going to get is 10x minus 6y equals negative 56. If I move this equation over here, so it's stacked underneath, I can tell right away that my y's are going to eliminate each other. 6y minus, or negative 6y plus 6y is going to give me 0. If I add these two, I'm going to end up with 14x. And if I add negative 56 and negative 14, I'm going to end up with negative 70. Solve the equation for x by dividing by 14, and I'm going to get that x is equal to negative 5. Now I can take this value for x, negative 5, and plug it into the original equation and solve for the missing y variable. Again, in this equation, right here there was an x. Now I know that x is equal to negative 5. So I can substitute negative 5 in for that x and then solve for the missing y variable. 5 times negative 5 gives me negative 25. Bring down the negative 3y and the negative 28, and I now have a two-step equation which I can solve for y. I'm going to add 25 to both sides. Bring down the negative 3y, and negative 28 plus 25 gives me negative 3. And I can solve the rest of the equation by dividing by negative 3, and I get a y value of positive 1. That means my solution for this equation is the point negative 5, 1.